Hey guys, today we're going to look at 1.1, which is going to talk about angles. We're going to review a little bit of things that you should remember from geometry, and then we're going to add on a few things that maybe are some new things that we're going to look at in our trig class. So the first thing to review is what is an angle? We've got a definition right here. An angle consists of two rays in a plane with a common endpoint. The common endpoint is called the vertex right here. And an angle measure is generated by rotating around the vertex. The two rays are the sides of the angle. The ray in its initial position is the initial side down here, and the ray in its location after the rotation is the terminal side up here. When we are looking at this particular class, we are going to be taking our angles and putting them in our coordinate XY grid, our coordinate plane. So we talk about positive angles with our terminal side going around in the positive direction. So our initial side starts on the x-axis and we go up in the positive y direction, and that's our positive angle. Our negative angle with our initial side starting on the x-axis goes down in the negative y direction. So positive angles go counterclockwise, negative angles go clockwise. The most common unit for measuring angles is degrees. We won't use degrees for the entire semester. We will use it for some of the semester. We'll switch between degrees and radians. Right now we're going to be using degrees though. And if we start at the x-axis with our initial side and we go all the way around to come back to our initial side, that would give us a 360-degree circle. So a complete rotation of a ray gives an angle whose measure is 360 degrees. Now, example 1 and example 2 are going to talk about some other relationships we should remember from geometry. Example 1 says for an angle measuring 40 degrees, find the measure of its complement and its supplement. So a complementary angle is an angle that adds up to 90 degrees with the other angle, and the supplementary angles add up to 180 degrees. So if I'm trying to find the complement of 40 degrees, let's go back to the right color. If I'm trying to find the complement, I would do 90 degrees minus 40 degrees to find that the complement is 50 degrees. If I'm trying to find the supplement, I would do 180 degrees minus 40 degrees, and I get that the supplement is 140 degrees. Okay, for example 2, if we look at our pictures, we need to find the measure of each marked angle. Remember that this little box right here means that it is a 90-degree angle. You cannot just assume it's a 90-degree angle. Remember, your pictures, while they may look like something, aren't necessarily that thing. So you need to make sure you see that box before you say that it's a 90-degree angle. So that means these two angles are complements of each other. They're complementary angles. So I can make an equation where I take those two angles, add them together, and it's going to equal 90 degrees. So 6x plus 3x is going to equal 90, which means 9x equals 90. I can divide both sides by 9, and I get that x is equal to 10. But do make sure that you were reading your directions, because it didn't say to find x. It said to find the measure of each marked angle. So I got to take that x and plug it back in. 6 times 10 is going to give me 60 degrees for this first angle up here. And 3 times 10 is going to give me 30 degrees for the second angle down here. Over here, I have a straight line, and then I've got two angles that make that straight line. To get a straight line, that's a 180-degree angle. So I can say that that 4x plus the 6x equals 180 degrees. So 10x is equal to 180. I can divide both sides by 10, and I get that x is equal to 18. So over here, 4 times 18 is going to give me that the first 4x angle is 72 degrees. Then over here, 6 times 18 gives me that the second angle is 108 degrees. So those are two examples that are kind of review from geometry. What might be new is that measuring degrees doesn't just have to be in decimals or whole numbers. So like here we had all whole number answers, but you could have had a decimal like 60.5 or 30.78 or something like that. We can also measure our degrees using minutes and seconds. So a minute is 1/60th of a degree, and a second is 1/60th of a minute, and 1/3600th of a degree. So if you think about minutes and seconds and how we talk about time, that makes sense because there's 60 minutes in an hour and there's 60 seconds in a minute. But you do have to make sure you're really thinking about it when we talk about our degrees and we talk about like decimals versus minutes and seconds. So for example, if I had 40.5 degrees, if I wanted to write that in terms of degrees and minutes, it would still be 40 degrees, but point 0.5 is a half. So I wouldn't write it as like 50 minutes or something like that. I would think about it being half. And I personally think about it like time. So I would think about it as half an hour, which means that it would be 30 minutes. And to represent minutes, we use an apostrophe. So you got to really, really think about it when you're looking at this. And then if we're talking about seconds, just a random example, if I had, let's say, 15 degrees, 12 minutes, and 14 seconds, I would use like a quotation mark or two apostrophes there to show the seconds. So degree sign, then the minute sign is apostrophe, and the second sign is the quotation marks. Now, you may be like, oh my gosh, I can't keep this straight. I don't want to have to think about like minutes and seconds and converting and all that kind of stuff. And lucky for you, your calculator can do it for you. So the first thing that you need to do is you need to make sure that you're in degree mode when we're talking about degrees. Make sure you are in the right mode when we are doing things in this class. Okay, we will be using degrees. We will also be using radians, and we might be using both of them in one unit on one test. So you need to make sure that you are always checking what your units are, what mode you need to be in, and don't forget that before you take a test, every single time I clear your calculator. So you need to always check what mode you're in. So let me pull up my calculator here, maybe. Come on. There we go. Okay. So you hit mode and you can see that the default mode for your calculator is actually radian. So you need to go and switch it to degree. And then what we're going to do is we're going to hit second and then we're going to hit apps. And it's going to open up the angle menu. So second and then, and you can see that the first option is the degree symbol and the second option is the minutes symbol. So I can use those to help me do the first part of example 3. So I'm going to type in 51 and then second apps 1 to get the degree sign and 29 second apps 2 to get the minute sign plus 32 second apps 1 and 46 second apps 2. So 51 degrees and 29 minutes plus 32 degrees and 46 minutes. When I hit enter, there's my answer. But you'll notice my answer is a decimal answer, 84.25. It's not in degrees and minutes. And if I am starting in degrees and minutes, my answer needs to also be in degrees and minutes unless it tells me otherwise. But once again, lucky for you, your calculator will convert it for you. So once again, you're going to hit second apps. And if you look in that menu, that same angle menu, option 4 has like a little triangle and then it says DMS. That's going to convert your answer to degrees, minutes, and seconds. So you hit option 4, then hit enter, And you can see it pops out my answer in degrees, minutes, and seconds. So it's going to go to 84 degrees, 15 minutes. And since it's 0 seconds, I don't actually need to write 0 seconds. So I can just say 84 degrees and 15 minutes. So lucky for us, the calculator will convert it. Okay, let's look at example 4. Or not example 4, sorry, part 2 of example 3 first. Skipping over a problem. If I do 90 degrees minus 73 degrees, and 12 minutes. Once again, it pops out a decimal answer, 16.8, but I'm going to do second apps 4 and hit enter to get 16 degrees and 40. You look at my calculator, it says 47 minutes and 60 seconds. But remember, 60 seconds is a full minute, so that's actually 48 minutes. Okay, you may have noticed in this menu that the seconds symbol is actually missing. It's in a different spot because I think the quotation marks are used for other things on your calculator as well. So to get the seconds symbol, you're going to hit alpha and then the plus sign. So for example 4, I've got 74 and then second apps 1 to get the degree sign, and then 8, second apps 2 to get the minute sign, and then 14, but then I'm going to hit alpha and the plus sign to get that seconds sign. And 4 says convert between minutes and seconds and decimals, so I'm trying to take this and make it a decimal degree instead. So all you have to do is hit enter and it'll pop out the decimal version for you. It does say to round it to the thousandths, so that would be 74.137 degrees. It is still a degree, so you do still need the degree sign on it. Then I have 34.817. That one is a decimal, and I need to change it back to degrees, minutes, and seconds. So I'm going to do 34.817. And then I can just do second apps 4, and it'll change it to my degrees, minutes, seconds for me. So that's still 34 degrees, but it's 49 minutes and 1.2 seconds. So our calculator can do all of those conversions for us. Then the last thing for this set of notes is that, like I said at the beginning, we will be taking our angles and putting them in our coordinate grid. So the initial side is on the x-axis. The vertex is your origin, your 0, 0. And our angles are going to go around in the positive counterclockwise direction. So that's how your quadrants are labeled. You start with quadrant 1 here, then quadrant 2, quadrant 3, and quadrant 4. And all the way around gets you 360 degrees, one full circle. So that circle, we call it the unit circle. We are going to be working with that a lot this semester. There are going to be some nice properties about the unit circle, some nice patterns that you'll notice. And there are going to be some things about the unit circle that you're going to memorize. So we want to, if possible, work with angles that are inside the unit circle as much as we can. So coterminal angles, and I know there's a typo here, coterminal angles are angles that have the same terminal spot, the same ending spot when we go around and around on the circle. Because remember, we're not limited to just angles between 0 and 360. So if I go from 0 to 360, well, then if I went another time around the circle, that would get me to 720. And 0, 360, and 720 are all coterminal angles because they all end in the same spot. So coterminal angles are angles that just end in the same spot. But what we like to do is we like to try and find the coterminal angle that has the least positive measure so that we're dealing with angles that are in the unit circle, since that's what we're going to be working with a lot this semester and we're going to be most familiar with this semester. So that's what we have in example 5 right here. It says find the angle of least positive measure that's coterminal with these angles. So the easiest way to do this is just subtract 360 or add 360 until you get to something that's between 0 and 360. So if I'm starting with 908 and I subtract 360 degrees from it, that gets me to 548 degrees, which is not quite there yet. So I'm going to subtract 360 again, and that gets me to 188 degrees, which is in between 0 and 360. So that would be my least positive measure angle that's coterminal with 908. Now the next one you notice is negative 75. So that actually means instead of going up and around, we actually ended up going down and around a negative angle. We still want a positive coterminal angle though, so instead of subtracting 360, now I'm going to add 360 to find that positive coterminal angle. So negative 75 plus 360 gets me to 285 degrees for my positive coterminal angle. And the same thing for this negative 800 over here. I'm just going to keep adding 360 until I get to something that's between 0 and 360. So when I add 360 the first time, that gets me to negative 440. Still negative, so I'm going to add 360 again. That gets me to negative 80. Still negative, so I'm going to add 360 again. And that gets me to 280, which is a positive angle in between 0 and 360. So that would be the coterminal angle that I want to use. And that is it for this set of notes that kind of reviewed some stuff about angles that you should remember from geometry and added on a little bit so that we are ready for some of the more complex trig stuff we're going to learn this semester. So make sure you get started on your assignment that goes with this. And if you have any questions, let me know. And you guys have a good day.